left off yesterday. We have a few more examples on the handout. The first example that we run into, I think we're going to skip. There's a graph. Skip that graph and go right to the tables there at the bottom of your page, please. It says determine whether the function is linear. Explain. Our function is linear if we have a constant rate of change. Okay, do you remember yesterday we talked about finding rate of change? It was a change in y's divided by change in x's. If we have a constant, if it's the same all the way through, then we know that we have a linear function. So let's look at these first two ordered pairs. Let's find the change in y divided by change in x. So 12 minus 6 is 6, and 2 minus 1 is 1. So our rate of change is 6. Go to your next two ordered pairs. Let's look at these two here and see if our rate of change is the same. 18 minus 12 is 6, and 3 minus 2? 6 divided by 1 is 6. Go to the third set of ordered pairs. 24 minus 18 is 6, and 4 minus 3 is 1. 6 divided by 1 is 6. We have the same rate of change throughout, so that tells us that this is a linear function. We would say that yes, it is linear, and our explanation, we would say it has a constant rate of change. Gavin, do you have a question?
What if it just goes up same amount on each side? Can you just tell that way?
Okay, as long as you're looking at both columns. Okay, if it's increasing by the same amount in the y column, let me rephrase it. If each y value is increasing by the same amount, if each x value is increasing by the same amount, not necessarily the same as the y, but the same from one x to one x. Yes, that's the same thing what we're doing.
I'm confused on when you do the graphs. How do you find rate of change? When we do that?
We're not doing that right now. You'll have to come see me during class. We're going to talk about it. Okay. This we're just looking at a table today and determining the rate of change. Go to example B. This is not your B. It would be your 10. They want to determine if this is linear or not. So let's look at our first two ordered pairs and find the rate of change here. So I'm going to do 1 minus 5, negative 4, divided by negative 2 minus a negative 10, negative 2 minus a negative 10. It's 8. And negative 4 divided by 8 is really negative 1/2. Let's look at the second group of ordered pairs. Negative 4 minus 1 is negative 5. 6 minus a negative 2 is 8. Negative 5/8. Right here I know my answer to the question.
No.
Is this linear?
No.
It's not. Why?
Because they all don't have the same rate of change.
It's not a constant rate of change. So I would say that no, it's not linear. Not a constant rate of change. This next one is multiple choice, but we're going to do it together. Look at our first ordered pairs.
Can't you tell on those that it's linear because they go up at the same amount?
That's essentially what we're doing. Okay, but I want you to show me your rate of change since we're practicing. 4 minus 2 is 2. 10 minus 5 is 5. My rate of change for those first two ordered pairs is 5. Look at your second ordered pairs. 6 minus 4, 15 minus 10, 5. 2/5. It looks to be the same. Let's go to the third ordered pair. 8 minus 6,
2.
and 20 minus 15, 5. It's the same rate all the way through, so what does that tell me?
Yes.
Yes, it is linear. The rate of change is constant. It would be letter A. This next one says determine whether the function is linear. Again, find your rate of change. 16 minus 12 and 6 minus 3 is 3. Your next two ordered pairs, 20 minus 16 and 12 minus 6,
3, 6.
6. Right here I have my answer.
No, not range.
It's not, because the rate of change is not constant. Letter D. Alright, that concludes our notes from yesterday. We're going to begin today's notes, which is dealing with slope. Dealing with slope. You're going to need to get out a sheet of paper from your notebook to write these examples down. There's probably not room on your handout from yesterday. When we talk about slope, we're talking about the rise and run of a line. The slope of a line is the ratio of the rise to the run. Have you heard of rise over run before?
Yes.
Rise over run. Today our focus is not on finding slope from a graph, but instead of finding slope from ordered pairs.
You need to write that down.
No, not just a second. There is a formula that we're going to use, and it's essentially the same formula we were using yesterday. We're going to find the change in the y's divided by the change in the x's. The difference in the y's divided by the difference in the x's. We use these little numbers. It's read y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. These little numbers, this 2 and this 1, are called subscripts. We use them to denote the difference between this y value and this y value. Because we'll have two ordered pairs, we'll have two different y values. It's just telling you the difference between this y value and this y value. That's the only thing it does. It doesn't mean square it or take it to a power or anything. It just tells you the difference between the two. So please write this down onto your notes if you haven't already done so. This is located on the wall in here. Do you know where it is? That is the midpoint formula. Zoe? Back there. It's right above Alex. In the back corner, bottom right-hand corner of the box, painted above Alex, it's on the wall. Guys, I did not. The teacher that was here before, Mrs. Quinn, had some students that did it. They came over the summer and did it. I will not cover these up on tests and quizzes. You will have access to these. On the EOC, you also have a formula page which will have those formulas on there for you. Formulas are only as good as you know what to do with them, right? If you don't know what to do with the formula, they don't serve any purpose. So they're there. You'll just need to know when to use it and why to use it. Okay? Here, let's look at a couple of ordered pairs where we're asked to find the slope. It says find the slope of the line that passes through negative 3, 2, and 5, 5. So on your notes, copy down these two ordered pairs, negative 3, 2, 5, 5. Remember, we use a slope formula. And this is exactly what we did yesterday. We just didn't give it a name.
So you mean by what? You mean by y2?
That's what I'm getting ready to explain. Each ordered pair has an x and a y value, right? So we couldn't just say y minus y divided by x minus x because we don't know which y and which x. So what I would want you to do is I want you to label your ordered pairs. The first ordered pair we'll call x sub 1 and y sub 1. Please do this. The second ordered pair is called x sub 2 and y sub 2. We could have called this first ordered pair x sub 2 and y sub 2, and the second ordered pair x sub 1 and y sub 1. That doesn't matter, as long as the sub 1s are together and the sub 2s are together. It's a matter of plugging into a formula at this point to find your slope. Y sub 2 is 5 minus y sub 1, 2, divided by x sub 2,
Negative.
5, minus x sub 1,
-3.
negative 3. It's just a matter of calculating now. 5 minus 2 is 3. 5 minus a negative 3, or 5 plus 3, is 8. Our slope is 3/8.
You want to go ahead and solve it or like take
You mean
it?
decimal?
3 divided by 8.
No, I want you to leave it as a fraction. When we talk in terms of slope, it is rise over run, and we'll need to leave that as a fraction. 3/8. I do want a fraction in simplest form, though, if you are able to simplify. Here's our second ordered pairs, set of ordered pairs. -3, -4, and -2, -8. Again, they're asking us to find the slope, so we're going to use our slope formula. We have x sub 1 and y sub 1, x sub 2 and y sub 2. Substitute into your formula. Y sub 2 is really -8 minus y sub 1, which is really
4.
not 4, -4, divided by x sub 2, -2 minus x sub 1, -3.
Do we change?
We do have -8 minus a -4. I would encourage you to add the opposite there. So -8 plus 4 is -4. The denominator we have 2 minus a -3. -2 plus 3 is really 1. -4 over 1 is really -4. I need you to simplify. Put your answer, your fraction in simplest form. Here's our next one. Please copy these ordered pairs down. -3, 4, and 4, 4. So again, I label my ordered pairs so that I know exactly where to plug into my formula. It's kind of foolproof here, guys, if you can do your algebra. Y sub 2 is 4 minus y sub 1, 4, divided by x sub 2, 4, minus x sub 1, -3. So our numerator reads 4 minus 4, which is 0, and 4 minus a -3,
Is that undefined?
we know it's not undefined. What is 0 divided by 7?
0.
0. What would the graph of a line with 0 slope look like? It would be a flat. Remember what slope dude said yesterday? He said this is 0 fun. This be along the long flat part. And this is 0 fun, so it would be a horizontal line. Yeah. When is it undefined?
Straight up.
Straight up and down. Remember he fell off that cliff? He yelled the worst curse word possible in math and algebra. He said, undefined. So when he falls off that cliff, it's a vertical line. That would be the undefined.
If there's 0.
Where would the 0 be to make it undefined?
On the R.
In the denominator. If it's in the denominator, that would make it undefined. In the numerator, it's just 0. Let's look at this one.
I got a quick question.
Yes,
So if like the denominator is 0, we just write undefined?
correct.
Alright.
We have -2, -4, and -2, 3. Let's substitute into our formula. So y sub 2 is 3 minus y sub 1, -4, divided by x sub 2, -2, minus x sub 1,
-2.
also -2. So it looks like we have 7 divided by 0. This time we have 0 in the denominator. What is our slope here, Cameron?
Undefined.
Undefined. Don't leave it as 7 over 0. It's undefined. And what would the graph look like? Zoe,
Straight vertical line.
straight vertical line that has a slope of undefined. So if the 0 is in the numerator, what is our slope?
0.
0. What is 0 in the denominator?
Undefined.
Undefined. Remember, when you're simplifying, I do want your fractions in simplest form. Please put fractions in simplest form. Alright, I'm going to stop here. We do have some problems from last night's homework that we didn't get completed that we need to do, as well as tonight's.
We won't be graphing tonight.
No, we're not doing any graphing.
Is that all?
Let me verify it for just give me a second.
I didn't do it.
We need to do the ones from yesterday that we weren't able to do because we hadn't learned them yet.
The ones that I did.
You can have any kind of ball.
Handy.
Except for the power.
You didn't memorize.
I got a lot of homework tonight.
So in addition to this that's written in black, I need what you to do what's written in green.
So black and green.
Please utilize your time. You do have quite a bit of time today to work.